Hey everyone, Emma here, and I'm going to be explaining my musical movement machine to you guys. So the big idea of this project is for the user to be able to have their music change as they move, whether that's changing the song to match their pace or whether that's changing the actual tempo of the song to make it fit better to the movement that they're performing. And basically what I'm going to do is just go through the patch, and then at the end I'll explain how to use the product. Okay, so the big thing in developing this project was getting accelerometer data out of the iPhone into the Max patch. So we do that with TouchOSC, and we use Osculator to create a network bridge to transfer that data. So it comes in up here. On UD Perceive 9000. That's the data from our iPhone accelerometer. And it comes in as raw data, and then we unpack it into its three respective axes, the X, Y, and Z. And then to make sure we don't get too many false triggers or to get a more realistic representation of the movement, we don't want too many triggers. We don't want things to be repped the wrong way. We have some filters where we make sure that certain values aren't passed in, and Bondo to make sure that we don't get too many false triggers. And then we move over here, and these triggers are now transferred into seconds in order to calculate the correct BPM per each sample. So how that works is over here we have a big bang, and we have a timer that reports the milliseconds between each elapsed bang. And that milliseconds is then converted into the BPM through dividing by 60,000 milliseconds. And then in order to have those BPMs convert to the samples that I have loaded over here, you can see I have samples 120 through 170. Maybe in the future I can have more samples or different songs, but for now, these are my BPMs. And so I don't want any other BPMs that would be out of that range. So if anything is below or above that, we make sure it's clipped, so that way we get something in the correct range. And in order to make sure that we don't get too many or too much data per se, and things are going all over the place and the thing's moving too quick before you really commit to a movement, we use DL Stream to record 5 checks of that BPM. And then we divide it by 5 to get an average. So here's where we pack that all, get it in 5 seconds, smooth it with a line of 120 to really make sure that we're having a correct check of your movement. Now the fun part, we now have 2 options over here. We have the round 10 object, and then we have this G2 switch object. So basically what's going on here, you have 2 options for when you use the musical movement application or algorithm. You can either change the song with your speed or lock it, what I like to call lock mode, where you don't change songs at all, but the tempo will change to how you move. That's done over here. We divide it and see what the 10th place is in order to change the signal over here and use time stretch in order to change the speed of the song without raising the pitch of the sample. I'll go over there later. Let's just talk about the BPMs for now. So let's say you're moving, you got a bunch of different bangs going on here, and the machine thinks you're moving super fast, so that's 170 BPM. It's checking ever so often, and we're using the 10th degree to change that time stretch for you. So that way, if you're not quite at 170, but you're close enough, it'll do the in-between for you. Then we go to exactly how we set the BPM. So we use a cell object in order to match the correct BPM that's coming in. And I had some clicking originally when I had developed it. So what we do here is we crossfade by turning the signal on and turning the others off, and using a crossfade time to see how fast exactly we will do that. We then unpack it into groove in a certain amount of time, and then we use a line object for the sig, and I'm sorry, yes, a sig, and then out of groove in order to smooth the signal and to combine them, whether they're crossfading, whether we're just focusing on one, and sum them all the way into our crossfade delay algorithm over here. So what's going on over here? We have a tap in object and a tap out object, and we use speed lim and cycle in order to crossfade between two signals at a speed in which we invert the crossfade, speed lim of whatever you choose. You use a crossfade so that way we never hear a click. One's always ramping up as the other's ramping down, which is a great way to avoid clicks. Let's move over here. The next part of the project had to do with the spatialization aspect of the project. So in order to get a cool thing for spatialization, we separate the highs, mids, and lows using cross objects, and we send them to our spat oper, which is all over here. Now, there's a lot going on over here, and perhaps this will make more sense if I first explain the stride development part of the project. So when this project goes into presentation mode, the first thing that happens is it asks you to put in your stride development. Let's put into presentation mode so we can see what I'm talking about. So here's the presentation mode. A big thing I wanted for my project was to be able to cite goals, whether that was how many steps you wanted to take or how fast you wanted to complete it in. So basically what we're doing here is developing a stride length. So that way we can create a sense of distance towards your goal. So I'm 5'2", I'm short, so I'm going to put 62 inches. I want to move 200 steps, and I want to do it in a minute, so 60,000 milliseconds. We calculate that. That tells me the distance in inches I'm going to have to move and how fast I'm going to have to move. Then next, I'll pick what mode I'd like to perform in, a video option if you want to see what you look like. And then here at the very end, you press the X to start the timer, and you press the sound button to hear this BPM that's been chosen for you and or the spat, which is what we're going to get to next. So we use the spat in order to tell the user how far away they are from their goal, which I'll take it out of presentation mode so we can see that. All right, so we move over here. We have all this going on. So if I open up the spat window, you can see here, we keep the lows at the front of the user so they have kind of a basis of how fast they should be moving just using the lows. And then you see this mids just flying around the user. The mids change with how fast you're moving, so you can see how fast you're actually moving if you're maintaining that speed. And then the highs are probably the most important part for the user when creating a goal. So how that works is the highs move as far away as you are from your goal, and as you get closer, they get closer to you, to the front of the user. That happens over here. We have a step counter algorithm where we count how many steps using the bangs that we've calculated or recorded before to see how many steps you've taken overall, and we count them. And then over here, we have a timer, so we see how fast you're moving, or how fast things have been going, how long you've had the machine on for. And then we compare these two to your step goal and your timer goal, and we see how fast can you get there in this time, and how many steps have you taken so far, and when will you reach that. We then scale it to equate to a sort of distance in your headphones. As you can see here, it's far away. If I start to perhaps click it as if I'm moving, I'll click it pretty fast. You can see that the highs are moving as I get closer to my 200 goal. And yeah, that's about it. I'm going to demonstrate this project now so you guys can see it in action while I move.